Hi, I am Rashani DeBell, and you are learning algebra. Hi everyone. In our previous lesson, we learned how to find the x-intercepts or the roots of a quadratic function using a graph. In today's lesson, we are going to learn how to find the x-intercepts or the roots of a quadratic function using the quadratic formula. Let us first start by finding out what a quadratic formula is. Solving quadratic equations by the quadratic formula. Our objective is to use the quadratic formula to solve quadratic equations. The quadratic formula, what is it? The solutions of the quadratic equation ax squared plus bx plus c equals 0 can be found by using the following formula. You can read this formula as x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. What this plus or minus means is that we can have up to 2 solutions for our quadratic equation. We can find one of our solutions when we evaluate it as negative b plus the square root of b squared minus 4ac divided by 2a. We can also find our second solution by evaluating at negative b minus the square root of b squared minus 4ac divided by 2a. Here's a fun song to remember the quadratic formula by, and it's sung to the tune of Pop Goes the Weasel. The quadratic formula is negative b plus or minus square root of b squared minus 4ac all over 2a. Now you try. The quadratic formula is negative b plus or minus square root of b squared minus 4ac all over 2a. One more time! Okay, maybe not. Using quadratics in real life. The quadratic function is used to model the motion or the path that an object takes when it is dropped or thrown, such as a ball or when a diver jumps off a diving board. When an object is dropped, it does not have an initial velocity, so we would be using the following formula: h is equal to negative 16t squared plus s. When an object is thrown, it does have an initial velocity, and so we would be using the formula h is equal to negative 16t squared plus v times t plus s, where h represents our height in feet, t represents our time in motion in seconds, s represents our initial height in feet, and v represents our initial velocity. An interesting thing to note, this negative 16 by our t squared is 1/2 of the acceleration due to gravity. On the surface of the Earth, this acceleration is approximately 32 feet per second per second. Let us now look at some examples in which we use the quadratic formula to find the roots or the x-intercepts of a quadratic function. In this example, we are asked to solve 3x squared minus 7x equal 11. Looking at the highest degree, which is my largest exponent over here, it is an x squared term, so I know that this is a quadratic function, which means I need to write my quadratic function in standard form. In order to write it in standard form, I need to have the equation look like this: ax squared plus bx plus c equal 0. In this quadratic function, I have the ax squared, I have the bx, but I don't have the c on the same side of the equation. So I need to subtract 11 on both sides so that I can get it in standard form. When I subtract 11 from both sides, my resulting quadratic function is 3x squared minus 7x minus 11 equals 0. Now that it's written in standard form, I will start by identifying my a, b, and c values. A is 3. It's always my term or my number by x squared. B is -7. it's always the number by x. And c is my constant, or the number by itself. Now I'm going to use the quadratic formula to solve this quadratic equation. And the formula is negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. From here, I'm just going to plug in my values for a, b, and c into the quadratic formula and simplify. I have negative times a negative 7 plus or minus the square root of negative 7 squared minus 4 times 3 times negative 11, all divided by 2 times 3. Negative times a negative 7 is a positive 7, plus or minus negative 7 squared is 49, so I have the square root of 49 times negative 4 times 3, which is negative 12, and then negative 12 times negative 11 is a positive 132, all divided by 2 times 3, which is 6. I can simplify inside the square root because 49 plus 132 is 181, so I have 7 plus or minus the square root of 181 divided by 6. Now the square root of 181 is not a perfect square, so I'm going to need to use a calculator to evaluate this. And because I have a plus or minus over here, this means that I am going to have two answers for x. I have x is equal to 7 plus the square root of 181 divided by 6. I also have x is equal to 7 minus the square root of 181 divided by 6. Let us first look at 7 plus the square root of 181 divided by 6. Pulling up my calculator, I've got 7 plus square root of 181 divide by 6. That gives me approximately 3.408. I'm going to round to the nearest hundredths, so this is going to be approximately 3.41. What this means is that my parabola is going to cross the x-axis at approximately 3.41. It's also going to cross the x-axis over here, and we can evaluate the negative. 7 minus square root of 181 divided by 6. That is approximately negative 1.075. Rounded to the nearest hundredths, that looks like approximately negative 1.08. So here are my two values for x. These are the two values where my parabola is going to cross the x-axis. Let us verify this by using a graph. Let us draw the graph of 3x squared minus 7x is equal to 11 in standard form. Here's what our graph looks like. Here are the 2 points where it crosses the x-axis. At this point over here, we get x is equal to negative 1.08, and our y value is 0. So here's our first x-intercept, or root. At this point over here, we get x is equal to 3.41 and y is equal to 0. Here's our second x-intercept, or root, for this quadratic function of 3x squared minus 7x equals 11. These 2 points match exactly with what we found using the quadratic formula. And that concludes our lesson on using the quadratic formula to find the x-intercepts, or the roots, of a quadratic function. Thanks for watching.